Good afternoon, class. We are looking at College Algebra Module 5, covering Chapter 9, Sequences and Series. Starting with the first question. Let's clean this up. All right. Let us write the first 5 terms of the sequence a sub n equals 9 times 1/4 to the power of k minus 1. Simply put, replace the k with 1, 2, 3, 4, 5, the first 5. So let's start with number 1. That makes this one 0. 1/4 to the power of 0 is 1. Therefore, the answer is 9. Let's replace the k with number 2. 2 minus 1 makes it 1. 1/4 to the power of 1 is 1/4 times 9 is 9/4. As long as we can show work for a couple of them, we can show work for more. And we're going to write the first 2 that we have come up with, and the rest of it you can work on them. A sub 1 is 9, A sub 2 is 9/4, so on and so forth. Here's the sequence. A sub n equals 2, A sub n minus 1 plus A sub n minus 2, where A sub 1 is 6, A sub 2 is 3. We want the first term obviously is 6, the second term obviously is 3, but let's go over something. A difference equation, also known as a recursive sequence, is an equation of the form a sub n plus 1 is f of a sub n, where a sub 1 is given, and f is a real valued function. A solution is a sequence of a sub 1, a sub 2, all the way to a sub n, satisfying the given difference equation. So we have the first one, we have the second one. So now let's come up with a sub 3 using this formula. According to this formula, if you want the nth term, you want 2 a sub n minus 1, 2 of the term before that. So in this case, a sub 3 makes it 2 times a sub 2 plus the one even before that, which makes it a sub 1. Therefore, a sub 3, according to this formula is 2 a sub 2 plus a sub 1. So we're going to plug in 2 times 3 plus 6. The answer is 12. So using the same format, we want to go with a sub 4. A sub 4 becomes 2 a sub 3 plus a sub 2 using the same format. Look at this format. It's important to understand any term is 2 times the term before that and the term even prior to that. So a sub 4 is 2 a sub 3. So 2 times 12 plus a sub 2, which we know it to be 3. 2 times 12 is 24 and 3 is 27. And again, when you find 2 of them, a sub 3, a sub 4, the assumption is you can continue finding everything else. So part A was 6, part B was 3, we found 12 and 27, and I'm going to leave it for you to find the next one, which is going to be 66. Determine whether the sequence is arithmetic, geometric, or neither. If the sequence is geometric, find the common ratio. So first, what are they? Arithmetic sequence. If you want to go recursively, a sub n plus 1 is a sub n plus d. That means you add a common difference. If you want explicitly, a sub n equals a sub 1 plus n minus 1 times d. D is the common difference or distance, they call it. In the case of a geometric sequence, recursively, a sub n plus 1 is r times a sub n. That means multiply the previous one by r. Explicitly, a sub n is a sub 1 r to the power of n minus 1. So if this is the case, in the case of a geometric sequence, there has to be a ratio. So if we divide these two, that means 0.25 by negative 0.125, we get negative 2. And this is not enough. because you have to check this one and this one and this one. I'm going to check one more. Negative 0.5, which is a sub 3, divided by 0.25, which is a sub 2. That is also negative 2. And you can continue with more. That's probably enough when you have two of them. Therefore, this proves it's a geometric sequence with the ratio of negative 2, or the common ratio of negative 2. Let's look at part B. We are going to do the same thing here, a sub 2 over a sub 1, that means 8 over 6. And then a sub 3 over a sub 2, that means 11 over 8, so on and so forth. We notice that the ratio of 8 over 6 on this side, it's 8 over 6. And on this side is 11 over 8. And they are not the same. And by the way, how do you know that? If you do the cross product, this is 8 times 8, 64. This is 6 times 11, 66. They are not the same. Also, we can look at them from the arithmetic point of view. That means 8 minus 6, a sub 2 minus a sub 1. Is it equal to 11 minus 8, which is a sub 3 minus a sub 2? They are not equal either, because this one is 8 minus 6, or 2, and this one is 11 minus 8, or 3. Therefore, it's neither arithmetic sequence nor geometric sequence. If you look at part C, you may recognize quickly, if I divide 1/2 by negative 2, I get negative 1/4. That means a sub 2 over a sub 1. And if I do a sub 3 over a sub 2, in other words, divide negative 1/8 by 1/2, I get the same. And that proves this is a geometric sequence with a ratio of negative 1/4. If you have any doubts, you can continue with trying more. But that's probably enough. You want to write the arithmetic sequence in the standard form, meaning we want to find a sub n. So what is given as we look at this? A sub 1 is 32. D is the difference between the two, 24 minus 32, and it's negative 8. Excuse me. And now that we have that, we're going to put it in the format a sub n equals a sub 1 plus n minus 1 times d. So a sub n equals a sub 1, which is 32. 32 plus n minus 1 times d, which is negative 8. Now, if we simplify this, the answer is minus 8n, and the 32 and 8, they add up to 40. And it's really a good practice to check. The way you check it is very simple. If you let n be 1, you get 32. If you let n be 2, you must get 24, and so on and so forth. Fill in the blank. 139 is which term of the arithmetic sequence? Well, what is given? A sub 1 is 1. D is 4 minus 1, 7 minus 4, 10 minus 7. You really have to check at least a couple of them. And so the difference is 3. And so a sub n equals a sub 1 plus n minus 1 times d. So a sub n is number 139. A sub 1 is 1. N is what's missing. Minus 1 times d, which is 3. And we're going to set that equal to 139. So let's plug in and set it equal to 139 to find the missing n. This is 3n minus 3 and minus 3 and 1, they add up to 3 and minus 2. If we set this equal to 139, we can find n, which gives us the term we are interested in. We are going to move the 2, becomes positive 2, and 139 is 141 when you divide by 3. You get 47. And if you have any doubts into a sub n, you can either in this formula or in this formula plug in 47 and it should give you 139. All right, let's answer the following questions. Find a formula for the general term a sub n of the sequence assuming the pattern of the first few terms continues. Okay, the pattern continues, so we need to find what we are dealing with. If you notice, the first term is 0.8, and if you divide 4 by 0.8 or 20 by 4, both of them, they give us 5. So the first term is 0.8. We either have an arithmetic sequence we want to find d, or geometric sequence we want to find r, and it's easy to see the ratio. 4 divided by 0.8 or 20 divided by 4, both of them are the same. 100 divided by 20 is 5. So this is a geometric sequence with the first term being 0.8 and r being 5. So we want a sub n. So a sub n is a sub 1 r to the power of n minus 1. And let's replace a sub 1 with 0.8 or with 5. So we get 0.85 to the power of n minus 1. In part B, we are interested in finding a sub 8. So all you have to do, replace the n with number 8. So this becomes 7 raised 5 to the power of 7 times 0.8 using a calculator gives us 62,500. Find the 9th term of the geometric sequence whose initial term is a sub 1 equals 4 and the common ratio is 2. Well, it's a geometric sequence. And the general form is a sub n equals a sub 1 r to the power of n minus 1, where a sub 1 is given and r is given. Since we want the 9th term, then we want a sub 9, n equals 9, which is a sub 1, which is 4, r to the power of 2 to the power of n minus 1, which is 9 minus 1 or 8, which means 2 to the power of 8 times 4. Use a calculator. By the way, you may recognize this is 2 squared, so they add up to 2 to the power of 10. By the way, this may be that this is 2 squared. This is 2 to the power of 8, so it's 2 to the power of 10. That may make it easier to calculate. We want to evaluate this expression, the summation of k squared minus 1 going from 3 to 7, meaning, plug in k equals 3, calculate it. Plus, plug in k equals 4, calculate it. 5, 6, all the way to the upper limit, which is 7. So let's plug in 3, 4, 5, 6, 7. 3 squared minus 1, plus 4 squared minus 1, plus 5 squared minus 1, 6 squared minus 1, 7 squared minus 1. And we know this is to be 9 minus 1, 16 minus 1, 25 minus 1, 36 minus 1, 49 minus 1. And we simply add them up. We get 130. Obviously, this is 8, 15, 24. Let's just put on top of it quickly. So this is 8 plus 15, 24, 35, 48. Write arithmetic sum using sigma notation for 9 plus 4 plus -1 all the way to -26. And I'm reminding everybody that in the recursive format, a sub n plus 1 is a sub n plus d, and explicitly a sub n equals a sub 1 plus n minus 1d. So what we need to do, we want to write it in the form of summation with a sub n, which means we need to find a sub n and n. So with the sigma notation, you want to write it in this format, n from 1 to n that you're going to figure out for this number. We want to find a sub n and n. All right, where a sub n, of course, is a sub 1 plus n minus 1 times d. And let's see if we can figure out the d. As you see, 9 is getting smaller to get to 4. So therefore, a sub 1 is 9. D is 4 minus 9, which is -5. And you can even try this one, -1 minus 4 is also -5. So you want to check and recheck. So this is the general format. And this is the first term. This is the constant distance. Let's plug in. Replace the a sub 1 with 9. N minus 1. Replace the d with -5. So this is 9. Let's distribute. This is -5n plus 5. And of course, -5n plus 14. That's your a sub n. So we got a sub n. Since we want to add this from the beginning all the way to number -26, we need to know what would be the n value for number -26. So we are going to say if this is a sub n, we set it equal to -26 to find the missing n. If I move the 14, becomes negative, I have -40 divided by -5, n becomes 8. Therefore, we have a sub n, which is this value, from n equals 1 to n, which is this value, 8. And of course, you can let n be 1 and then 2, 3, all the way to 8. Add them up. We can also add them up, and they must be equal. This is a sigma notation of the same question. The summation of 1 to 14, 3 times 2 to the power of n minus 1. Again, reminding you of geometric sequence, arithmetic sequence, and so forth. So to evaluate this, let's just write out a few terms to see what we are dealing with. 3 times 2 to the power of n minus 1. If I plug in 1, becomes 2 to the power of 0, which is 1, so 3. If I plug in 2, becomes 2 times 3, 6. If I plug in 3, 3 minus 1 is 2. 2 squared is 4 times 3 is 12. So 3 plus 6 plus 12. And it continues indefinitely, which means we are dealing with a geometric sequence with A1 or A to B number 3, and R is the ratio of these two. 6 divided by 3, 12 divided by 6. Both of them obviously 2 because you have to check it. So now we want this summation. And this summation has the formula S sub n equals A sub 1 times 1 minus R to the power of n over 1 minus R. Let's plug in A sub 1 is 3, 1 minus, R is 2 to the power of n, 1 minus 2. Now, what is n? N is 14. N is 14. And of course, you have to put it into a calculator to come up with the answer. This is obviously negative 1. So you raise 2 to the power of 14. Whatever that is, you subtract it from 1, which gives you a negative number times 3. And divide by negative number gives you a positive number of 49,149. So that is the concept of the sum, or they call it the partial sum. Find the partial sum S sub 11. So this was S sub 14 for the arithmetic sequence where A sub 1 is 9, D equals 3. And in the case of an arithmetic sequence, S sub n is n over 2, A sub 1 plus A sub n, or if you use the fact that A sub n is this one, if you replace it here, then A sub n and A sub n becomes 2A sub n. So you can replace this with this. This is what we have. And so let's plug in to this formula. This formula, A sub n, replace it with 9, D, replace it with 3, and the n, replace it with 11. So this is your n, everybody. So obviously 11 halves, this is 18, this is 10 times 3 or 30, and 18 and 30 is 48. 24 times 11 is 264. Find the infinite sum if it exists for this geometric sequence series. So to do that, first and foremost, if it's a geometric series, we need to know the first term. A sub 1 is negative 2. We need to know the ratio. And by the way, sometimes they just call it A instead of A sub 1. You divide 0.5 by negative 2. You also divide negative 0.125 by 0.5 to make sure it's correct. When you do that, you can find R to be negative 1/4. And I highly recommend you do both just to be on the safe side, making sure you haven't made a mistake. Now, R is between negative 1 and 1. When that happens, if you look at this one, when R is between negative 1 and 1, this goes to 0 as n gets larger and larger, it goes to infinity, R to the power of n goes to 0. And so we have this expression, and again, in some cases, they just call this A. So putting it into this will give us the infinite sum. The first term is negative 2, 1 minus negative 1/4. Of course, minus 1/4 and minus makes it plus 1/4. The denominator is 5/4. And minus 2/5/4 is minus 8/5. I hope you see how that works. This one is the same as negative 2 times 4/5. We want to do the same thing here, and either you notice just by looking at it that this is a geometric sequence with 1/4 being the R and 9 being the first term, or just write it out. So let K be 1. If K is 1, this is 0, 1/4 to the power of 0 is 1, so it becomes 9. If you let K be 2, becomes 1, so 9 times 1/4 is 9/4. If you let it be 3, 3 minus 1 is 2, 1/4 to the power of 2 is 9, is 1/16 times 9. So this is what we get, and we recognize this as a geometric sequence with the first term being 9 and R being 1/4. Because R is between negative 1 and 1, we can use this formula. And again, I'm going to repeat, in some texts, they just use A. They call this one A. So plug in 9 over 1 minus 1/4. As you can see, this is 3/4. So 9 divided by 3/4 is the same as 9 times 4/3. 9 and 3 cancel each other. 3 times 4 is 12. So the final answer is 12. Let's look at some applications. On each swing left to right or right to left, a pendulum travels 90% as far as on its previous swing. If the first swing is 10 feet, determine the total distance traveled by the pendulum before coming to a complete stop. In other words, it starts going from point A to point B and coming back. Initially, that's 10 feet. Now, the next one, due to friction, becomes a tad less, becomes 90% of that. In other words, the second one would be 90% of this, or 0.9 times 10, or 9 feet. And this thing continues indefinitely until it stops. And so this is a geometric sequence with the first term, A sub 1 or A being 10 feet, and R being 0.9. And that's really the key. 90% is referring that it's being multiplied by it, and that gives you the fact that it's a geometric sequence with R being 0.9. And because R is between -1 and 1, we are going to use this formula. So all you have to do, plug in 10 instead of A sub 1 and 0.9 instead of R. As you know, 1 minus 0.9 is a 0.1. 10 divided by 0.1 means 10 times 10, or 100. And same unit, 100 feet, same unit. That is extremely important. Here's another application. A ladder consists of 31 rungs. If the rungs taper uniformly from 18 inches to 28 inches, how much material would be needed for the 20th rung? In other words, the first one is 18 inches, then it gets larger and larger and larger and larger from 18. And they get larger uniformly, meaning we add just a little bit. And we keep adding the same amount until we get to the last one, 31, and that is 28 inches. So this is an arithmetic sequence. N is 31. The first one, A sub 1, is 18. And A sub 31 is 28. And we are looking for A sub 20. So first, let's see what the question is asking us. Let's quickly go over that again. Since the length increases uniformly, it's an arithmetic sequence. So we are adding a little bit. We don't know how much yet. How many? You have 31. N equals 31 because there are 31 rungs. The first one is 18. The last one, A sub 31, is 28. We want to find A sub 20. So what we are going to do, we are going to use the fact that A sub n is A sub 1 plus n minus 1 times d. And so for number 31, we put A sub 1 plus 31 minus 1 times d. And for 18, we put 20. This is A sub 1 is 18. We plug in and we find the missing D. Remember, A sub 1 is 18. So let's plug in for A sub 31, and let's plug in 28. For A sub 1, let's plug in 18 plus 30 D, and we don't know what D is. We subtract the 18, we get 10, and D becomes 10 divided by 30, or 1/3. And by the way, the units are whatever units that you have here. So that means the first one is 18 inches, then we add 1/3 of an inch to this one, becomes the second one. Then we add another one, becomes the third one, so on and so forth. And so now that we have this, we want a sub 20, which is a sub 1, according to this formula, plus 20 minus 1 times d. And we know a sub 1 to be 18, and we found the d to be 1/3. Let's plug in. And of course, this is 19/3. You may recognize 19/3 means 6 and 1/3. 6 and 18 is 24. So 24 and 1/3. And as I mentioned, don't forget the units whenever you're dealing with the applications. And the units are in inches. Finally, how much material would be needed for all of these 31 rhombs? Well, that means we want to find S sub n is n over 2 a sub 1 plus a sub n. And we can use either this formula or this formula. Since we have a sub 1 and a sub n, it's easier to go with that. We replace the n with 31. A sub 1 is 18. A sub 31 is 28. They add up to 46. And (23 times 31) is 713 inches. That's the total amount of material we need.